Hello, everyone, and thank you for joining our live session today. My name is Larissa. I'm an event planner at Reactor, joining you from Brazil. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. This session is being recorded and will be available to view on demand here on the Reactor YouTube channel within 48 hours. Keep an eye on the chat. We'll be dropping helpful links and checking for questions. I'll now turn it over to our speaker for today. Thank you all and hello. Welcome, Pamela.
Hello, everyone. Welcome to the final session in our Python plus Agents series. Thank you, everyone, for joining us along the way and for joining this final session. If you missed any of the earlier sessions, you can watch the videos, grab the slides, go through the write-ups. All of those resources are available for you to keep learning. And yeah, you can also, if you're inspired, you can give this course yourself to your, friends, family, loved ones, whoever you talk to. So for our final session, we are going to be talking about adding a human in the loop, both to agents and to workflows. And this is really, really important, as we'll see, because we're working with LLMs, and LLMs are nowhere near perfect. So I'm very happy that we get to talk about this today. So we're going to talk about, why it's so important and show different ways of bringing human in the loop into agents and then into workflows. Discuss how to do checkpointing, which is something helpful for human in loop workflows, especially ones that happen over time, and then end with another cool end-to-end application. So if you do want to follow along, we have this repo that we've been using throughout the series. So you can go to the repo and you can click the code button, and then you will see a big button, Create Codespace on main, and that will open a VS Code in the browser that has everything set up. And when this opens in Codespaces, it will use GitHub models by default, which are free models that you can use with your GitHub account up to a certain rate limit. And I think for these examples today, we can use, I think that they all fit within the rate limit. So hopefully you are able to run all the examples today for free with GitHub models. Just let us know in the chat if you have any issues with following along with the code. If you do already have the code checked out, do run git pull this morning, afternoon, whatever, to make sure you have the latest changes, because, sometimes I make little tweaks to the code between our sessions. So let's recap what we've been talking about this week is agentic workflows. An agentic workflow is a flow that involves an agent at some point. It's usually to handle decision-making, to decide, where to go next in the flow, or it's to synthesize some information or structured output. Now, we are specifically using Microsoft Agent Framework in this series. And in Agent Framework, a workflow is a graph that has executor nodes and edges in between. And many of those executor nodes could be agents, but they could also be custom nodes that do any sort of processing or data lookup. So we are going to be building on top of agents and workflows in today's session. Now, we want to bring humans into the loop in these workflows with these agents. And we want to bring humans in the loop because oftentimes an agent wants to take an action, right? We're giving agents tools. And some of those tools are actions that actually affect the world, right? Affect something about the environment. They are actions that are write operations, right? The agent can send an email, can post a comment, make a report, like all sorts of write operations that actually have a real consequence. And many times in that case, we want to make sure that that action really should be taken. And if we don't have 100% confidence in the agent, then we want to send that to a human to review first. And this is generally a good practice right now when we're building things on top of LLMs, because LLMs have a tendency to make stuff up. That's actually that's like a feature as well as a bug. Just, they are generative, LLMs are generative AI. They are generating responses. And sometimes those responses are not exactly the response that we want it to be, right? And if we are giving the LLM access to tools, it might say like, oh, I want to use this tool to do this thing. And that tool could be an actual write operation. And actually, we don't want that to happen, right? So a lot of times when we're giving agents the ability to take a write action, we do want a human to review it first. I think we've all seen this in the past few weeks with OpenClaw, which is like an agent that gets full access to like email and your operating system and all that stuff. And even a safety researcher from OpenAI, like they were using OpenClaw and they realized that OpenClaw basically deleted like half their emails in their inbox because it decided to start deleting emails, even though that's not what the person asked them to do, right? So they had to scramble to like shut off their OpenClaw, right? So if you are giving an agent the ability to do something like, like delete email, send email, etc., you really want to be in the loop and reviewing all those actions first. So just to reiterate, why are the reasons we're adding a human in the loop? As we said, like, LLMs are generative and they're producing all kinds of outputs, and those outputs are not always correct. So when we add a human in the loop, it can give us accuracy in terms of verifying facts are correct, safety for sensitive operations, trust, so that users will just have more trust when they see that they're the ones explicitly giving the agent the ability to take that operation. Right now, users rightfully may not have trust in an application that's entirely driven by an LLM. And if you tell them, okay, don't worry, we're always going to ask for your approval before we do this thing, well, then the user can have a higher level of trust, right? Compliance, you may need compliance. You may need an audit trail of human approvals for workflows in particular domains. And just general control, right? Like you can have your workflow just might work better when you bring a human in at particular points because the human just has more expertise in deciding what should happen next in the workflow. We have various ways of bringing human in the loop and agent framework. These are the ones we're going to talk about today. Tool approval for agents, workflows, request and responses, checkpoints and resumings, particularly helpful for long-running tasks where humans are involved. And then we're going to look at that handoff architecture in particular and see how to bring human in the loop there. So first, let's talk about tool approval for agents. So if we don't have tool approval, what happens? Agent can decide to send an email or delete all the emails in the inbox. That tool executes automatically, and then that email got sent, and maybe that email was wrong. And for something as important as email, you may not want that to happen, right? So if we add in that approval step, then the flow is going to be that the agent decides it wants to send an email, and the agent pauses, and the human gets this this prompt that says, hey, are you sure you want to send this email? And the human says yes or no. And only then does the tool execute, right? So we basically want to pause at the point that an agent decides which action it wants to take, if it is a sensitive action, a sensitive tool. So you should consider having tool approval for any sort of financial operations, right? Anything with a bank. We'll see a banking example later today. Any communications, any destructive operations, deletions. I had Copilot delete a resource group the other day without asking me, and I was very offended, right? Like, you should ask me before something like that. Generally, any irreversible action, right? So how do we do this in Agent Framework? So earlier we saw how to define tools using that tool decorator. Now what we're going to do is specify the approval mode for each of our tools. So the default is never require, but we can change that approval mode to always require. So let's actually check this out in the code. This is agent tool approval. So up here, we've got a few different tools. So lookup receipt, this is just a read operation. This is not a big deal. So we're just saying that we're never going to require, which is the same thing as just leaving it off. But here we're being really explicit and saying, okay, this is a tool and it never requires approval. And then here we have a tool where it always requires approval. And this is for submitting an expense report, because this is a, an actual write operation that's going to, add something to the database, right? So if you think in terms of database operations, a select is not a big deal as long as you have authorized access to that information. But any sort of update, insert, delete, those are generally big deals, right? So in this case, we are saying that we need to always require for this tool. Now, when we build the application around this agent, we need to intercept these tool approval requests, right? So what we do is that we run our query. So here's a simulated user query, and we tell the agent to run on the query. And then what we do is we loop through and see if there's any user input requests. So if there are any user input requests, because there could actually be multiple, because you could actually have multiple tools and it could decide to call multiple tools at the same time with parallel tool calling. So there could, in theory, actually be multiple. So we loop through and see, okay, for all of the user input requests, we're going to look through them. We're going to look at each request, and we're going to look at the function call for that request, and look at the name and the arguments. And we're going to tell the user, like, hey, your approval is requested for this tool with these arguments. And then we're going to add the fact that we requested that to the conversation. And then we're going to ask the user's input, do you approve this tool? Right? So we're just doing the command line, approve, yes or no. And then once we get that response, there is a special function you can use to indicate that the function got approved. So you just say request to approval response, and that indicates whether it was approved or not. And then we run the agent with the new messages in there. So the agent sees, okay, we wanted to make the tool call, and the user said either yes or no, and now it can decide what to do next. So let's actually take a look at this. So UV run examples, agent tool approval.py. So let's see. So here on our agent here is just an expense agent and just has access to those two tools. So remember, this one, it doesn't need approval, and this one it does. All right, so the user asked it to look up the receipts and then submit an expense report for both of them. And we got approval requested, submit expense report. Here's the description. So these are all the arguments that are getting sent to the function. And we can say yes. And now we see that I approved it. And now the agent's going to process the fact that it was approved. And it says, okay, done. I submitted a report for both of them. It also looked up the receipts. We didn't get an approval for that because it didn't need one. It just did it behind the scenes. Now we could also try seeing what happens if we do not approve it, right? What will the agent decide to do in that case? I actually don't know. I've never tested that. I mean, I think the agent will be like, oh, okay, sorry, we can't do that, right? Rejected. So now the agent has to decide what to do when its tool gets rejected. Okay, and in this case, it's just, this is kind of interesting. This is something you need to think about in terms of when you're developing your agents. Like, if the user rejects it, should the agent keep asking, which is what it's doing in this case? Or, maybe you put in the system prompt like, okay, if the user rejects it, then you say, sorry, I can't help you today, right? Because this experience probably isn't as good. So that is something definitely to think about once you're having this human loop, is what should be the experience and how should the agent handle if the user rejects that, right? With GitHub Copilot, I do often actually reject things it does. And then the Copilot will be like, oh, okay, well, we're not allowed to do that. I'll come up with a different way, right? In this case, this agent has so few tools, it doesn't have any alternative way to submit the expense report. So it's just kind of struggling, and it just keeps asking if it can do it, which is, good on it for being persistent, but probably we should put in the system prompt, that if they reject, you just say, okay, sorry, I can't help you today. You could also add some sort of middleware to detect how many times a particular tool call has been attempted and rejected. All right, so there we go. That is our tool call approval for agents. So this is just on the agent level itself. Now we're going to look at workflows. Workflows are, what we build around agents and other executors. And workflows have their own way of doing human in the loop. So let's look at this diagram here to see how it works. We've got application code, which is like our actual, outer Python code that's setting up the workflow. Then we have the actual workflow executor code, like the code that's inside that executor class. And then we have the human. So we start off with running our workflow and sending a message to it. And then the executor looks at that message, and it may decide that it needs information from a human in order to proceed. So it tells the context. So every executor receives a workflow context. It tells the context, hey, I need to request information, and says which information it needs. So our application code is handling events for the workflow and sees that there's been an event of this type. So we need to actually have explicit code that is looking for this request info event type, so that then we can handle it. So in that case, we get that event, the workflow is now effectively paused, and we then prompt the user in some way, right? So we say, hey, user, we need some information. That goes to the human. Human gives input, goes back to our application code. And then we add that information to the responses to our list of messages and send that back to the workflow and say, okay, workflow, you can resume now. Here is the information that you wanted. So then the workflow response handler receives those new responses, and the workflow can resume. So that is the general flow. The changes it requires is that our workflow executor needs to request info at some point, and our application code needs to be looking for that request info event. So we're going to look at a simple chat with human in the loop workflow. And in this workflow, we're going to have a chat coordinator executor, and we're going to have a chat agent, which has an LLM. And the chat coordinator is going to decide when it needs to request information from the human. Basically, it's going to keep requesting information from the human until the human says done. If the human says done, then it'll conclude the workflow. But if the human says anything else, then it's going to keep going. So let's actually look at the code, because I think that'll be clear. So this is workflow HITL requests.py. All right, so let's look at how we set this up. So we've got this agent here that is just a really generic, LLM assistant agent. Then we have this coordinator, and the coordinator knows about the agent. And then we set up a workflow that starts on the coordinator, and the coordinator goes to the agent, and the agent can go back to the coordinator. And the user can just ask a generic question like, what are fun things to do in Seattle? So then we send that message to the workflow. And then we have this loop here that is processing all the events that come back in the stream. So we're streaming back the events so that we can process those events, so that if we see a request info event, then we say, oh, there's this pending request here. And then we go through all the pending requests and say, hey, the agent has a question for you. And we get back info for the user. So the user can type anything there or type done. And then we run the workflow with these responses here. And basically these responses is a dictionary that maps request IDs to replies. All right, so imagine the workflow has a bunch of pending, it has potentially multiple pending requests. And on the event, there's this request ID here. And we add our reply to that for that request ID, so the workflow can see, oh, okay, I had that request, and that request got a reply, right? It needs to see that it had that request and that it got a reply. So now let's look at the actual workflow code here, right? So, in the chat coordinator, when it first gets just a standard message from the user, it tells, it just sends that to the chat agent and says, hey, respond. And then when it gets a response from the chat agent, then it actually requests information, right? It says, oh, okay, let's ask the user for its response. So it's just coordinating this back and forth between the LLM and the user. And then when we get a human reply, so this is taking a different type here. So this is a reply coming from the human. We check to see, hey, are they just saying done? In which case, we're going to finish this workflow. Otherwise, we're going to send on the user's message to the chat agent. So even I said it was a simple chat workflow, but even that is, there's a fair amount of complexity in there, and seeing how we set up the coordination. All right, so let's just run this so we can see. And one thing I should know is that there are two different decorations here. So we have the handler one, and the handler decoration is the handler decorator is the one we add just for generically receiving messages from other executors. So, there's these two executors in this workflow, and whenever this executor receives something, it's going to check to see which of the handlers should receive it, right? So this handler can process any message that's just a string, whereas this handler processes messages that actually come from the chat agent. So you can see, basically it's gonna, the input is going to prompt that first handler, and then the return from the agent is going to prompt that second handler. And now this one is using the response handler decorator. So that one is specifically for handling responses from humans. So we're only adding this one because we are doing human in the loop. All right, so here we say, okay, we started the chat. What are fun things to do in Seattle? The agent says to visit some places. I say, I want to dance. Okay. And so then that, so in this case, it's going through this code here where it gets, it's getting a response from the user and says, oh, okay, the user did not say done. So I'm going to send a message with the user's response to the chat agent. The agent says, heck yes, go dancing. Okay, great. If I want to dance right now. Okay, right now, I'm going to turn the place into a mini club. Let's go. Okay, not right now. That'd be awkward. So every time I send a response here, right? So every time I respond here, it's adding my response to this dictionary of responses to request IDs and sending those back to the workflow. And then this executor is receiving it here and deciding what it's going to do. All right, and now I'm just going to say done. So done then goes and triggers this, which says, okay, yielding output and not sending any messages, and that means the workflow is just done, right? If we yield output and don't send a message, then there's nothing more to be done in this workflow. And their conversation ended. Okay, so there we go. That is adding a human to a workflow. So the key things here, once again, is that we need to intercept that request info event. And when we intercept that, we need to build a dictionary of request IDs to responses that we can then send back to the workflow. And then in our workflow executor itself, we need to have a something that will request information when we want information, only when we want it. In this case, we wanted it a lot. And then something that will be a response handler that processes the replies from the humans. Okay. So that worked. Now, of course, the thing I didn't like about that is that we were relying on just this free text, just the string done to decide, the flow of the conversation. And if you've been watching, this series, you know that I love structured outputs. So let's look at how we could add structured outputs into a workflow so that we can be a little more structured about when we decide we need more information from the user. So as a reminder, structured outputs is basically a way of getting the LLM to produce JSON that conforms to a particular schema. And it's really helpful for workflows whenever there's a decision point, because then you can be much more confident that you're making the right decision based off the LLM's analysis. So for this workflow, we're doing this trip planning agent. And it's similar in that we do have the trip coordinator that is coordinating with this agent that has an LLM. And this LLM is using structured outputs. So when this LLM responds, it is always going to respond with a structured output. And in that structured output, it's going to say whether it needs more information from the human or whether it's got a complete trip plan, right? So if it has a complete trip plan, we can just output it and say, here's your trip plan. But if it needs more information from the human before it can develop that plan, then that's when we're going to request information from the human. So let's go ahead and look at this code. This is workflow HITL requests structured.py. All right, so what we can see here is that we've got an agent, which is the trip planner agent, and this one uses this planner output in order to, whenever it's responding, it's going to use planner output. So let's look at planner output. That will give a status of need info or complete. And so this is how we're going to know whether we need more information from the human. And then it has optional question or itinerary. So basically, if it needs more info, it's going to ask a question and stuff it in here. And if it's complete, it's not going to have a question and it's going to stuff the itinerary in this itinerary field. So that's our trip planner agent. Then we have our coordinator, and that's the one that has all the code for managing the information requesting. And then we set up the same workflow topology as before. So now let's look at that coordinator code. So the coordinator code, similarly, we've got the start handler, and that takes in the string. And when, at the start, it's just going to directly send that to the trip planner. It's like, okay, this is what the user wants. Start figuring this out, right? Then whenever it gets a response from the trip planner, it's going to turn that response into, this Python object. And it's going to check to see, okay, is the status need info? And it has a question. In that case, it's going to request information. If not, that means the trip is complete and it can just yield that output. And then we have this handler here that handles human answer. So this is that @response handler. And whenever it gets a response from the human, it just forwards it to the trip planner agent. And then the while loop down here is very, very similar. It's basically just only the emojis are different, really. All right, so let's try this out. Workflow, HITL, requests, structured. All right. Let's see. So we started it with, I want to go somewhere warm next month. So that gets sent to that agent, and the agent asked me a question, right? So that means, since it asked a question, that means that the agent came back with a status of need info and this question, right? So that's why I'm seeing this question here. So we're like, so I'm just say Costa Rica. Always, always Costa Rica. All right, it says, what are my exact travel dates? Okay. March 20th to 26th. And well, there we go. That should be enough information about the travel dates. And what's my budget? The other day I did 3 million. Okay, we'll do 3 million again just because it's fun. You should always mess with LLMs when you're working with them, because then you'll get to like really see how they respond. What do I mean? CRC just for me, baby. All right. And I think it's going to have one more request, because basically, we told it what information it needs. It needs all this information. And so it's going through and asking all this. So find what activities, volcanoes. They have this nice volcano that's erupting all the time in Costa Rica constantly. Okay, so it, as you can see, it was continuously coming back with need info, because in the system prompt, I told it, like, listen, you need to find out their destination, their dates, their activities, and their budget. I told it that it needs to find out those 4 things. So it's really helpful in the system prompt to be very clear to the agent, like, this is the information you need to find out before you can proceed, right? Because if you don't, it'll either ask for too much or too little. So you want to be really, really clear. All right. So then finally it came back, which means that it, and we see the itinerary. So that means that finally it said output status is complete, and it made an itinerary, and that is what we outputted here. Yeah, and great. Going to Arenal. All right. Leaves plenty of headroom within my budget for upgrades. Yeah, 3 million's a lot, I guess. Okay. All right. So there we go. So I think that's a nice approach to being able to decide when it is that you're going to ask the human for more information, is to use those structured outputs. Now, it does mean you need to use an LLM that supports structured outputs, but as we've talked about, most of the frontier LLMs do have built-in support for structured outputs as part of their training process. Okay, so there we go. So we've seen how to bring humans in the loop for agent tool approval. We've seen how to bring humans in the loop for workflows. Now we're going to look at how we can do checkpoints and resuming. And this is particularly helpful when humans are involved, because humans are not always available. So we may need to pause a workflow and wait for the human to be available. And we need some way of resuming these paused workflows. So yeah, why do we need checkpoints, right? If we don't have a checkpoint, the workflow is going to pause and ask for human input. The human may not be there. They might be gone. They might be in Costa Rica. Who knows? And then, what is the process going to do? It's probably going to just crash at some point or quit. And that means all the progress is lost. So once we add checkpoints, the workflow can pause for human input. If the human may be offline, you can save the checkpoint to disk or database, wherever. The process can safely exit because all the information has been saved. And then hours later, when they're back from their volcano trip, we can restart the process, load the checkpoint, let the human provide input, and then the workflow can resume. So this is what a workflow lifecycle looks like once we have checkpoints, right? So we've got our original process. We run the workflow requests information, and the human's not there. We save that checkpoint, and the process can safely exit. And that checkpoint gets saved somewhere, often in a database. And that checkpoint includes everything that's needed to resume that workflow. So basically everything about that workflow. So we've got the states of the executors, we've got the shared state of the workflow itself, we have any pending requests, and we have the full messages in the workflow, right? So then we can tell the workflow to rerun from that checkpoint using its particular checkpoint storage, and it'll find that checkpoint ID and restore the checkpoint. And if there are any pending requests, it will re-emit that request. And so that's really important, because remember, we always have that event loop that's checking for request info events. So when it restores that checkpoint, if it sees any of those pending events, it will re-emit them. So that way we can catch them and say, oh, human, we need you right now. So how do we set up checkpoint storage? The agent framework does provide two built-in storage mechanisms. One of them is just an in-memory checkpoint storage, and the other one is a file checkpoint storage. We will see how to actually use the database as well, since these ones don't feel very, very production ready. Depends on your use case, though. So in our example, we're going to try out the file checkpoint storage. So we just give it a path to a directory. And then when we set up the workflow, we specify that this is the checkpoint storage we're using. So we associate our workflow with a particular checkpoint storage. And then when we're actually running the workflow, before we run it, we check to see if there's any checkpoint ID associated that we should be using. So if we find that there's a checkpoint ID, then we're going to rerun from that checkpoint ID. Now, normally you'd be like associating this with a user, right? Like the user's logged in, you check to see like, oh, is there any like checkpoint ID for that user? In this case, we don't have users, so we're just going to kind of check globally if there's a checkpoint ID. But in production, you would probably be associating this with a user, a session, some sort of way of figuring out that there's the current person has a checkpoint. And then we have our normal event processing that can process the workflow. Okay, so let's go ahead and check this out. Workflow, HITL, checkpoint.py. I'm also going to make sure my checkpoint directory is deleted. It is. Okay, great. Okay. All right. So let's see. So we're setting up this file checkpoint storage just with a local directory. And we set our checkpoint storage here. And here's the code where we check to see. So here I'm just looking at all of the checkpoints in this one. So I just looked at all of the checkpoints and I just grabbed the latest one, right? So I was saying like in production, you'd probably be associating checkpoints with a user. But in this case, I'm just kind of doing it globally and just saying, all right, just if there's a latest checkpoint, we're going to resume from that. And if not, then we just run from the beginning. Okay, so let's actually try this out. So UV run examples, workflow, HITL, checkpoint.py. So right now it is listing checkpoints. It did not find any at all. So it started the workflow here from scratch and says, okay, we're starting it with this brief. And here is a draft. Please approve it. Now, at this point, I'm going to exit the process. So I'm just going to Control-C to simulate exiting the process. And then I'm going to show you my directory. You can see there is now a checkpoints directory, and you can see there's actually 3 checkpoints. So the checkpointing happens at multiple steps in the workflow. So in this case, there are actually 3 checkpoints, and you can even see what's in the checkpoints. This is all, in this case, it's just stored as in the file, so you can see it. There's some pickling here as well for the Python objects. But you can see, you can look at these and see also, this was the 0 iteration. This was 2. So this one looks like it's the most recent one. And you can also check timestamps here. So you can see its checkpoint ID, its previous checkpoint ID. You can see if there's any state, executor state, the full conversation, the pickled message objects. Those are Python objects that have been pickled, which is a way of turning Python objects into strings. And all of this will get restored when we resume the checkpoint. And then the important thing here is that you can see pending request info events, right? So here you can see, there is an event that when this workflow is resumed, this event should be emitted, right? So that's a really crucial part of the checkpoint. Okay, so now when we rerun it, what it should do is list those checkpoints, find the one that has the most recent timestamp based off that timestamp field we just looked at. and then restart the checkpoint from that workflow. So here you can see found 3 checkpoints, resuming from latest, and we don't see, that initial prompt anymore. We just see this event, human approval needed, review the draft, and now I can say approve, and now it says workflow completed. And so if I run it one more time, it's going to see even more checkpoints, right? So let's see, found 6 checkpoints, resuming from latest, and then there's nothing to do because this workflow is complete. So resuming just means, boom, the workflow is done. So there we go. So that's the idea of checkpoint storage. The workflow is going to store multiple checkpoints along the way, not just when you request information. It's just basically after each step in the workflow, it's going to store a checkpoint. And then you need to decide how you're going to find which checkpoint ID you want to start off from. But as long as you associate that checkpoint storage and have a way of deciding on the checkpoint ID, then you can resume from that checkpoint. Now, you probably, if you're designing workflows that are going to be running on servers, especially for like user-facing applications, you may want to implement your own checkpoint storage that stores in a database. So how do we do that? We can implement a storage class that implements the checkpoint storage protocol. So this class has to define how to save a checkpoint, how to load a checkpoint, how to delete a checkpoint, list checkpoints, and get the latest checkpoint. Oh, I should probably have that would have been easier to use. Okay. Probably I could replace my code with get latest. I forgot that was an option. Now there is the built-in backend, the built-in storages for file and in memory, but basically you can write checkpoint storages on your favorite database of choice. So for today, I'm going to show how to make one for Postgres. So we're going to make a table where we store the checkpoint IDs, the workflow name, the timestamp, and then the actual checkpoint data. And, when coming up with this checkpoint storage, we do have to make some decisions, right? How are we going to scope that checkpoints? Is it a global workflow that's, just, running the same for everyone? Or are these workflows that should be scoped to a particular user or session? How long do you want to keep the checkpoints around? Like, do you want to keep them around forever? Do you want to prune at some point? How large are the checkpoints? Are they going to fit in your database storage? Like, what kind of type should you use for them, right? Like even with Postgres, I was deciding between the binary type and the JSON type. So you decide, how you can properly store them. And then who can access checkpoints, right? Like if they're user scoped, how are you going to make sure that nobody is able to resume from somebody else's checkpoint? So those are all things to think about when you're doing these checkpoints in production. So in order to do checkpoint storage with Postgres, we do need to set up a table. And then when we save a checkpoint, we're going to save that checkpoint into the table with its ID, its workflow name, its timestamp, and the data. And then when we load it, we're going to do a select to pull it back out. So let's go and actually check out the Postgres code. So workflow, HITL checkpoint PG. And let's go and look here at our Postgres code. So when we construct it, we make sure that we have a table that has these columns. So, this is everything we need in order to implement all the required functions. And we also create an index on there so that we can get by timestamp, so we can get latest. Then when we save, we are pickling. Now, you do have to be careful about pickling in general because pickling has some security issues. But in this case, we're pickling data that is under our control. So that should be OK. I wonder, what is this no QA? OK. But you do, generally you do want to be careful about pickling. But in this case, pickling is fine to do. Then we connect to the database and insert the checkpoint into the database, and we return the ID of the inserted checkpoint. Then when we load, we're going to get that checkpoint from the database, and we are going to unpickle it. Then we can list checkpoints for a particular workflow. We can delete a checkpoint, and we can get the latest by ordering by timestamp. So that's basically our checkpoint storage. And then, the rest of the code is similar. We do have to have this code here. I didn't show this before, but whenever you're doing checkpointing, you need to make sure that you are saving the executor state. So you actually implement this on checkpoint save and on checkpoint restore method that says how this executor state should get serialized and how it should get, restored. Okay. Then we create our checkpoint storage. We pass that in to our workflow builder. And then I really should use the get. So I did list checkpoints here, but in fact, we could just do await storage dot get latest. Let's try that. If checking it then, that should return back a single. Okay. All right, there we go. That looks nicer. Let's try this out. So we're going to run this example here. Okay. So if it has a checkpoint, it's going to resume it. If not, it's going to start the workflow with the brief. So here we can see it has started from scratch. And it's going to ask us for some input. And once again, I'm going to Control-C out of here. And then I'm going to open up my Postgres database and show you that I now have a table called Workflow Checkpoints. Here I'm using the VS Code Postgres extension, which is really, really nice. Highly recommend it. So now I can inspect this table and see what's in it. And you can see there are 3 checkpoints. And the data is entirely pickled, so it just looks like a binary blob. But this is similar to what we saw before, stored locally, but now it is in our database, right? So there's 3 checkpoints. So now I'm going to rerun this workflow again. And it says, okay, found a checkpoint in Postgres, resuming from latest, human approval needed. Let's approve it. Great, workflow completed. If I rerun and look at the checkpoints, we can now see 6 checkpoints. So it's really the same thing, except now we are storing our checkpoints in Postgres instead of storing them in a local file system. So hopefully you can get an idea for how you could make your own checkpoint storage with your favorite database. Okay, so now we're going to look at how to use the built-in handoff workflows with human in the loop. So we talked about handoff yesterday, and we didn't have humans in the loop then, and we actually saw that handoff was a bit funky without humans. So handoff is really designed to work well with human in the loop. So that's what we're going to see now. So as a recap of what we talked about yesterday, handoff is a built-in workflow where any agent can hand off to any other agent. None of the edges are defined up front. By default, the routing is just determined based off of the current conversation state. Now, handoff works the best when you have a user there, because an agent can decide to request user input if it's not sure what to do next, or if it doesn't have enough information. So when an agent doesn't hand off, it might instead request user input. The workflow will emit a special event, the handoff user request event, and the application can handle that event and present it to the user so that it can then pass back the information for the workflow to resume. So in order to set up Handoff Builder for interactivity, you actually just set it up the normal way, and you just make sure you do not set with autonomous mode. So yesterday we set this with autonomous mode because we didn't have humans in the loop. But today we're just going to set it up. And by default, it will be able to request input from the user. And so the important thing is that when we are looking at events, we need to check and see, hey, is this an event? Is this a user request event? If so, let's get information from the user and then, send it back to the workflow in the responses. So this is similar to how we were handling human in the loop for just generic workflows. Here, it's just a slightly different because handoff has its own special event class that it's emitting. And it's even got a special built-in method for creating a response in the format that it likes. But generally, it's the same idea, is that we're going to build up a dictionary that maps request IDs to responses and then rerun the workflow with those responses. All right, so let's just actually try it out here. Okay, workflow handoff. So here we have this customer support handoff. It has a triage agent, order agent, return agent. It does start with a triage agent, but once it starts off, all the agents can hand off to each other. And then in our event processing, this is what's changed, is now we're looking for particular kinds of events. So we're looking for this one, request info. And that will add that event, and then we can look through that and get the actual user request, and then send that to the user. So let's go ahead and run this and see what happens. All right, so we started it off with the request. This is from me. Hi, I need help with an order. So it's going to get passed to the triage agent first, and then the triage agent is going to decide what to do. All right, so can you tell me your 3-digit order number? Order 123. My order was damaged. I want a refund. Okay. So now it has to decide where it's going to hand off next. And it's handed off to the return agent. That sounds good. All right, it says, okay, you'd like a refund, confirm by replying yes, right? So every time that I'm responding here, it's this here where I'm giving my user input. And here, if I decide to exit or quit, it will actually terminate and tell the whole workflow to terminate. So you have a way of getting out of the workflow if you need that. But otherwise, if I don't say exit or quit, then it's going to say, okay, this is the reply. This is the response to this request event, right? And then it reruns the workflow with that dictionary mapping request IDs to responses. All right, so I confirm by saying yes. All right, and as you see, it decided to call a tool. I didn't put tool approval in here. That'd be fun to add tool approval as well, but it asked for my approval too. Now return decided to send handoff back to triage. Triage decided to hand back to return. Return says, okay, it's done. I'll hand you back to the team. Let's see if it'll actually hand me back. Return is going back to triage. Okay. It's really fun to see when they go back and forth because they can't decide. All right. And hi, you're welcome. Is there anything else? No, I am good. And let's see if it'll terminate. Now, the workflow as a whole has a termination condition as well, where when anyone says goodbye, it just terminates. So triage agent said goodbye, and the conversation is ended. So there you go. So, handoff works particularly well when users are involved, because oftentimes the agents do need some additional information or guidance to figure out what to do next. Now let's look at an end-to-end application that uses that handoff workflow that I just showed and involves a human in the loop. So this is a very cool application from my colleague David, who's in the chat, or at least was earlier. And you can actually check out the code yourself and deploy it yourself on Azure if you want. It uses agent framework, fast MCP, and then on the Azure side, it uses OpenAI, document intelligence, container apps, and it's a very nicely done demonstration. So in this application, this is a banking assistant application. So I have it open here, and it's like a personal home banking assistant, right? And it has various MCP servers and agents, right? So on the MCP server side, those are built with fast MCP, and it has an account service that can get account by username and get credit cards. We've got a payment service to submit bills. We've got a reporting service, to get transaction information. Then on the agent side, these are all using agent framework. We've got a supervisor agent, account agent, transaction agent, and payment agent. And each of these have access to different MCP servers, right? So account agent only accesses the account service, transaction accesses accounts and reporting, and payment accesses all of them, plus an additional tool that uses document intelligence to scan invoices. And then we have a supervisor agent, which is basically the triage agent in this case. It's called supervisor, but it is, since we're doing handoff, this is basically the same as the triage agent that we were just showing. So it's going to decide, where to send people to. So the code is similar to what we've seen, is that we have that, that triage agent, and then it passes off. It's involved in the same, it's got these other participants, the account agent, transaction agent, and payment agent. And it does also have checkpoint storage too. So you can see how they've implemented checkpoint storage. So let's actually try this out. So on the website, I can pull up this chat. And this chat is built also using OpenAI Chat Kit, which is a cool way of easily getting interactive chat UIs for your applications. And Agent Framework has an adapter that will turn the Agent Framework output into something that works with Chat Kit. All right, so I'm just like, get my last 10 transactions. Okay, so here you can see it's connected to the transaction agent. It retrieves my account. So these are tools that it's calling, right? Like get last transactions. Here's my last 10 transactions. Okay, great. Now, the next thing I want to do is, list my payment methods. All right. So that is retrieving my accounts. Okay. All right. And now let's try paying. Let's see, pay a bill. Let's try uploading a bill that I have. It's a fake bill. So pay my bill. Okay. So here, okay, Evite. Retrieve my accounts. Let's see if it's going to hand it off to the account thing. All right, I'm going to reload it. Okay. Whoop. Let me make this bigger again. And then try pay my bill. All right, here we are connected to the payment agent. So the triage agent passed off to the payment agent. It's using document intelligence to extract the data from the uploaded image. And it extracted these details from it. Please confirm that these are correct. Okay, I'll say looks good. And now it's looking at my possible accounts. It's fetching my account deal. So it says, here's my available payment method. So I'll say Platinum, Visa. It's processing, fetching my credit card details. Okay, it has sufficient funds. Confirm. And now what we see is there is a tool approval required. So here you can see we're using the handoff architecture, but one of the agents, the payment agent, has approval required. So you can combine, basically this combines everything we looked at today, right? We're using handoff, we're using human in the loop, we're using checkpointing, and we're using tool approval. So this is how it's rendering this tool approval action. So it's okay, it requires your approval. And here's the information. We're going to say approve. And now that is going through. Now that we approved it, hopefully it will pay our bill. While it's doing that, here's the actual code. So you can check out, you can look and see all, all the code that is involved. Here you can see we do have special, we have a special check for this function approval request, since we are doing tool approval here as well. And I think it's still going through there. So there you go. So you can get an idea for how you might build user-facing applications that involve a lot of the components that we saw here, with with having multiple agents, with human in the loop, with tool approval, with checkpointing. So many interesting ways that you can combine these things in order to create these workflows. And I do think it's really important to think about how you want to bring human in the loop into these applications, because to reiterate, LLMs are generative, and sometimes what they generate is not what you want them to generate. And so you really want to bring humans in at those crucial points so that you get the advantage of LLMs. They are very powerful. There's a lot they can do, but also still have checks in the process so that before anything really mission critical happens and something gets submitted into a database, that you have a human that's in that loop there. So this was our final session for the series. I hope you enjoyed it. I certainly learned a lot developing the curriculum for this series, and it was really fun to use Agent Framework, and I have more ideas myself about how I'll actually use it for my everyday life now. I hope you all start using Agent Framework and do share, what you make, in our community channels, like on Discord or on LinkedIn, because it's great to hear how people are putting agents and workflows to use in their, in their actual lives, work and personal. So we do have our final office hours after this session in Foundry Discord. So once I close this stream, I'll go and open up Discord. So if you do have any questions still pending that we didn't answer in the live chat, then come on over to Discord, and we've got plenty of time there to talk through it. If you missed any of the earlier sessions, all of the resources are available on this resources page. We've got just so many resources here, right? We've got the videos, the slides, the write-ups, the code, the office hour recordings, the office hour questions, some other helpful resources. So lots there for you to recap if you missed anything. And do also let us know if you have ideas for what future topics you want to see in series. Gwen and I love doing these English-Spanish live stream series. So far we've done Python plus AI, we've done MCP, and now we've done Agent Framework. If you have ideas for what topics you want to see in the future, do let us know, because I think it's a lot of fun. So we just need to figure out what our next series is going to be. All right. Thank you, everyone. I hope to see you in the Discord. Bye.
Thank you, Pamela. Thank you all for joining, and thank you all to you all who are watching our recording. And we are always looking to improve your experience. So if you have any feedback for us, we would love to hear what you have to say. You can find the link to the survey on the screen or in the chat, and we'll see you in the next one.